So this is mostly going to be about station setup, whether it's mobile or what we call a base station. And obviously, the most important thing is your radio transceiver. In most cases, if it's like a base station, you're going to need a power supply. They're designed to essentially operate off of a 12-volt battery. So you have to have a separate power supply or a battery to operate most of them. In the case of your handhelds, the battery's built in.
I was being curious about that. Why is that? Why can't I just plug into the melt lamp? There must be a reason.
I don't know.
There must be a reason.
I think it's
buy an expensive
because
radio, you gotta buy an expensive.
I think it's
other
because they want it to be portable. And in a lot of, in fact, majority of them either have, they come with a handle on it, or you can buy an accessory handle so you can pick it up and carry it. You know, take it out to a park and operate, you know, do a POTA or QRP or something like that. I just got a new one, 7610, and it's a big rate. It weighs 18 pounds. It's got a handle.
You're not gonna be moving around very much, 18 pounds.
It's heavy.
Plus you have other equipment that goes with
Yeah,
it.
you got a power supply that weighs
Exactly.
10 pounds.
And then the antennas and all the other stuff.
Okay. If you intend to do any of the digital modes, you're also going to need a computer. Very few of the modern radios have a computer built in. There's a few. They're not really like ICOMs and Yaesus, but some of the more for hobbyist stuff where you can go and play with the firmware yourself and do mods and things like that. In addition, you need a microphone, speaker, cables to hook it all up. The Handy Talkie has everything included. It's got the microphone, it's got the speaker. A base station, you need all the other accessories. And you need to consider grounding, particularly for lightning protection, which we'll talk about a little bit more with base stations. And obviously you need an antenna, which is another thing that comes with your Handy Talkie, but in your base station, you need to buy a separate antenna and coax to hook it up. So doing a base station turns out to be a whole lot more complicated and expensive than just doing a Handy Talkie. And I think I lied the other day when I said there was no more math. We do have a math question.
But I knew you were going to lie about that.
But it's really easy.
All right.
No such thing.
Your transceiver, depending on how much power you're transmitting, you can consume a lot of current. And that's one of the things you need to take into consideration if you've got a base station and you want to buy a power supply for it. And most of the power supplies are designed to put out 13.8 volts nominal, which is actually what a 12-volt charged battery puts out. So you have to get a power supply that's capable of putting out the necessary current. I gave an example. I have an ICOM 7300 and transmitting at 100 watts, it's going to run at between 18 and 20 amps out of that power supply. So if you figure out the wattage, you know, at 13.8, let's say 14 volts, 20 amps, that's 280 watts in for 100 watts out. So you know, if you buy a 100-watt radio or a 50-watt radio, you need to more than double whatever that is to figure out what size power supply.
So these things are energy based for the most part.
Yeah,
Uh-huh.
you know,
That is.
there's no free lunch.
No, it's, you know, 2-to-1 ratio is kind of.
Well, but you're also drawing 2 or 3 amps and receive.
Okay.
So the receiver's in there too.
That's where some.
Right.
Let's see.
So transmit's probably 2 to 1. Or in that range. And because of the high current, you need to use heavy gauge wire as short as possible. Also, if you're doing mobile, that's another consideration on how far away your battery is. You need to make a direct connection to the battery. So you probably want to run something like 10 gauge wire to it. If it's too small, a gauge wire, you're going to get a fairly large voltage drop and drop 1 or 2 volts. So, and a lot of these transceivers don't operate below 12 volts. Or at least they don't operate very well. And one of the things they'll do is create a lot of spurious sidebands when the voltage gets down in the 12-volt range. I tried it once, they have an adjustable power supply, and you really could see the spurs coming up on the spectrum display.
There are recommended configuration, it's optimal.
It's optimal.
Can you
well-
have too heavy a gauge wire where it starts to work.
No, it's
Yeah,
just
sure.
more expensive.
Okay.
I mean, you could put an 8 gauge or a 6 gauge in there. That's pretty big
Right.
wire. It's a little overkill.
That's what I'm saying.
If you had a long piece, use it.
Right, it doesn't adversely affect it going the other way where.
No,
The gauge is counterproductive.
the lower the resistance, the better. So here I just showed you how you calculate, and the question coming up has you do this.
Okay.
So if you had a 50-watt transceiver, you're gonna need a minimum of 100-watt power supply. And probably need more
That's
safety
true
margin.
For those things as well.
Well, but you don't have any control. The battery's built in. But I think this is 4.5 amp hour
I
battery.
get it, but they design, I mean, you're at their mercy to, did they get the design right with the battery?
And a lot of them, you can buy a larger battery. More amp hours, so it lasts longer. And that's one of the things for the calculation is how long you want to operate. That determines how many amp hours you need in the battery. So why are short, heavy gauge wires used for a transceiver's DC power connection?
Minimize voltage drop. in transmit.
Eh?
Okay. I'm assuming everybody's seeing the slides.
Yep, I can see him.
Okay.
Yes,
Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? Most of your mobiles are probably more like 50 watts than 100.
This is one of the math things, right?
That's a math thing,
I don't.
but you don't necessarily, you should be able to do it in your
Uh-huh.
head.
I should be able to, but I'm gonna go Bravo, but it could be Delta. I know for a fact it's one of those 13.8s.
Well, what do we know? It's 50-watt output. So we want at least 100 watts in, right?
Yeah.
At least. So it's giving you volts and amps. How do you get watts out of volts and amps?
I don't know.
E
Good point.
equals. Or
Multiply 'em.
P equals IE.
Yeah, P equals IE, right?
And you know I and E? So what's P for those four?
So it's 12 times 13, right? I guess. So it'd be the Delta then. Right? No. That's too much.
Well, and remember, most of them are designed, I haven't seen any that aren't, for 13.8 volts. So you got two on there that are out of spec.
so Delta would be the closest.
Alpha,
So it wasn't hard, was it?
See all this here?
Yeah,
Like, I don't get that.
what?
It's
Well,
50 times
With
squared
50, we had
over 13.
a 50 watt okay, I just multiplied by 2, so 100. You should probably multiply it maybe 2.5. Okay. And you multiply, or you divide that by the 13.8 volts. So power divided by volts gives you current.
So technically is overkill by, a few amps there, but that.
Yeah, but it's probably closer to real life,
Right,
because the
yeah.
7.25 is probably marginal.
Right, okay.
You wouldn't operate as long. I mean, you'd operate.
Most instances. that's right.
Yeah. Most of the time,
Quotes in Allen. More power.
more power.
Right.
So when you want to do any of the digital modes, like I said, excuse me, you need a computer. And in most cases, it's not built in. So you have to know how to hook it up. And your computer will normally have an audio in and an audio out. Sometimes they're labeled mic and speaker or headset. Your radio, if it's capable of doing digital modes, will have a in and out. And obviously you want to connect your computer's output to your radio's audio input. Okay. And your computer's input to your radio's audio output. And some of the newer ones where you connect it with a USB cable, it generates virtual audio connections instead of the physical, like RCA jacks. But you still have to select the proper in to out and out to in, even on the virtual one. So, either way, you got to do speaker out to line in and microphone in to speaker out, or whatever. And that's usually what they're labeled, but it could be something slightly different. Basically, it's in to out and out to in. This is showing a typical setup. This is one of the QRP type radios that you can buy as a kit and build. And it's showing your audio in and audio out connections and the antenna and power.
You can build a QRP radio.
Oh, yeah. $100.
That's interesting.
There's a lot of them. QRP Labs sells a bunch. Foursquare QRP, something like that does a number of them. So what signals are used in a computer radio interface for digital modes? Charlie? Charlie sounds good.
You transmit key in case one of you.
The NMEA, and I forgot what that stands for, is the location information from GPS. That's the format that it uses. So if you had a radio and you were doing APRS or Whisper, that would be your source for that information to send out. How are transceiver audio input and output connected in a station configured to operate using FT8, which is a digital mode?
E.
Bravo.
Bravo.
And I don't know that I mentioned, but WSJTX is a software suite that has I don't know, maybe 10, 12 different digital modes within it. FT8, FT4, is it JT9, Echo, Whisper, all those things are part of that software.
So FT8 is part of WSJT.
Right. It's one of the modes that it supports.
So you would need that one to. be
You
able
put
to do it.
WSJTX on your computer and you configure it to talk to your radio. There's like a pull down menu, you tell it what your radio model is. And then you configure your audio in and outs to it. And a virtual control line for push to talk.
I thought they were like parallel, like either or, but it's together.
Yeah. There's also a FL Digi, similar, but it has some other modes. These are weak signal modes, which is what the WS stands for. So it was developed by this, I think it's Jim Taylor, for doing deep space communications. And they use the same protocols and stuff to do these amateur radio things, meteor scatter, moon bounce, it's all part of that. Which of the following connections is made between a computer and transceiver to use computer software when operating digital modes? Kind of the same thing we did, only asking it differently.
Charlie?
Delta.
I would vote for Charlie. In other words, in to out, out to in. So your speaker connection is an output. Okay, the accessory stuff. Because you got cables, you can pick up stray RF and it can cause distortion in your received audio. It can do some other malfunctions, but basically distortion is the big one. One of the cures is to use ferrite chokes or ferrite beads, which are either on the cables when you buy them. You can find USB cables and other audio cables with the ferrite chokes built in. They cost a lot more, or you can get what's called clip-ons. It's actually a bead that's split in half and it clips together over the cable. Because once the cable's made with connectors on it, you can't slide a ferrite bead over the connector. So you have to use a clip-on.
I thought those things are magnets.
No, it's ferrite. It's a mixture
I've
of,
seen them as.
it's a mixture of iron and magnesium and some other oxides all pressed together. It has a high permittivity. Can't ever remember if it's permittivity or permeability. I think it's permittivity. And there's what they look like. And they have a little plastic shell on them with some clips that will hold it, snap it together and hold it. And they come in various sizes. You can get an assortment off of Amazon, about 4 or 5 different sizes in a box. Or you can buy better quality ones from Palomar Engineering or some places. The Amazon ones come from China. So you actually don't know what you're getting. But they kind of work.
Everything comes from China.
Well, no, I had some stuff here recently from Taiwan. Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable?
A ferrite choke.
That was a hard one.
That was a gimme. Come on. I'm okay with that. Don't get me wrong.
Yeah, well, you could get that one on the test.
Fingers crossed.
Okay, grounding. That also helps avoid some of the interference that you might get. Without good grounding, and you can get RF common mode on the shield of your coax cable going to the antenna, coming into your receiver. And since that shield will be connected to the case of the receiver, the entire case could have RF potential on it, and it could affect other things. So that's one of the main reasons why you want to have a single point ground where your transceiver is outside, because you want to divert as much of that common mode to ground outside your shack before it gets inside. And normally you'll have some kind of interface where you come through window, the wall, however you're getting from outside to inside. You can buy kind of like an entrance panel, they call it. MFJ sells them that will fit in your window. You just raise the window up and it's a panel that you can put in, and it has feed-through connectors already mounted on it and ground lug and everything you need. Or you can make your own out of a copper plate. A lot of people you will see in some of the stations, like some of the club stations where they have several radios set up, they may put a maybe a 1-inch copper pipe fastened to the wall as their single point ground, and everything inside connects to that, and that will connect through your panel to your ground rod outside to make it a single point ground. The idea is to have the least amount of resistance between every point to ground.
You're saying they put a copper pipe on a wall and then they connect it to the ground from your breaker.
Right. It's just a low resistance connection for everything.
Not a separate,
Well, you could do them all to that plate either. It's easier usually to have something spread out that has a lot of mass, a lot of conductivity. Particularly if you got 3 or 4 radios along a bench and you want them all connected. So you have shorter runs to the copper pipe.
Okay, I'm gonna say something that I think is like one of those duh moments. I thought you meant that you would have this really big copper pipe and it went down into the ground, like you needed to dig a really deep hole. You're meaning to lay it flat across the ground so it has a lot of contact with it on its side.
Actually, we're talking about inside the building to connect your equipment to.
Okay, so
Outside, you would have a ground rod. You go to Home Depot or Lowe's,
right.
and they're 7 or 8 feet long. It's a steel rod that's copper plated.
Yes.
You drive it in the ground.
So okay, so it does go in vertically.
There's two things.
7 or 8 feet
There's
deep.
2 things. She's putting it together as one. It's 2 different things. The grounding rod goes in the ground,
Right.
which you already have 1 or 2 in your house already.
Yeah, but you don't, it's usually not where your shack is. And
If your shack is in your house,
But
yeah,
I would have it connect, like say I wanted to use this window panel. So I would have
Okay.
all the wires go to the panel and connect on one side. And then on the other side, I would have the copper wire coming out, connecting to something that goes vertically into the ground, not horizontally laying across.
correct.
Okay. Okay. So then I wasn't crazy. All right.
Okay.
I had like a vision in my mind. I'm like, wait a minute. Does he mean lay it across? No, it really is that deep a hole. Okay.
Well, it's only, they're like 5/8 diameter.
Okay.
I'm not sure where you're at. In Florida, you almost don't even need a hammer to put one in the ground.
I'm in Virginia. We're clay.
Well, then you might need a driver.
Yeah, I'm like getting below like topsoil is hard here.
Yeah.
But I'll do it. I got tools, I got power tools. I'm that kind of girl.
Okay. You can do it with a sledgehammer, just put something over the top of the pot, over the rod, so you don't mash the top of it all over, because then it's
Well-
hard to put a clamp on.
But I'm
Yeah.
thinking that I can use, there's an outlet on the wall there, and that ground is still good. No,
No. Think about it. That is probably a 14 gauge wire, the safety ground. That's going from all your outlets
Yeah.
back to
I didn't see that.
your entrance panel where it gets connected to the power company's ground rod they put in for you. It's very small gauge wire. And you need, when you put your ground rod or rods in at your, outside your station, wherever it is, you need to connect that to your utility ground rod with at least a 6 gauge wire.
Okay.
Because otherwise, if you had a lightning strike on the power line, it's going to come in through that safety wire to everything AC plugged into it.
Mhm.
Okay, which is a fairly high resistance, so you're going to get a big potential across it. It's not going to be diverted to ground very well because you don't have a good ground connection. It's there for safety to keep you from getting electrocuted. It's not for lightning protection. That's why it's just a small wire. I think lightning is 50 to 100,000 amps. You get like 10 strikes in a few microseconds.
Right.
It's serious. If you have a direct strike, all this stuff, it won't matter. You're going to lose something or have a fire. But if you get one close, it can induce a fairly high current also, and can protect you against that. A direct strike, you're kind of,
Screwed.
yeah,
Little if anything can take that kind of
right.
power and that short of a burst.
The commercial buildings where they actually do use lightning arresters, the old Benjamin Franklin thing, which he got wrong, but it worked. If you have heavy enough gauge conductors, and it will actually attract the lightning, but it's got to be able to carry that kind of current to ground. And you won't do it on a number 6 gauge wire either.
I'm gonna be on audio, so I'm gonna close my door.
Is there a better material if you're willing to pay for it than copper?
No,
Copper's the best.
well, maybe silver.
Okay. Well, that's what I'm saying, if you're willing to pay for it,
Pipe.
is there?
Copper's bad enough now. It's really getting expensive.
They stopped making pennies out of it. That's how expensive it is.
They did that in the Second World War too. They were copper plated. I still have some. This is a picture of copper strap, which is actually recommended to connect things, particularly outside, to go from your entrance panel down to your ground rod. It's not real easy to make connections with it, but because of the surface area, it will conduct a lot of current and has very low inductance. Inside, you can use this braided copper strap, which has a lot of surface area. That's fairly easy to put like ring connectors on it. You don't use it outside because it will oxidize and the braid doesn't hold up well in the weather. The copper will just get a nice green coating on it, but it still works. Patina, yeah.
Robert, question.
Okay.
It has a low inductance or a low impedance?
Well, because it has a low inductance, it would have a low impedance because it also has a low resistance. And impedance is the vector sum of the resistance plus the reactance. So it has low inductance, it'll have low reactance.
Well,
Okay.
I wasn't meaning that as a trick question. Maybe I'm confused over what the impedance, basically, I'm gonna say this in a stupid way. What's the resistance of an inductor again?
Well, a perfect inductor has zero resistance. But will have inductance, which is reactive with frequency. Remember,
Okay,
resistance.
because there's a question on there somewhere on that test where you mix up inductance and impedance. I remember that.
Yeah, I think so. There's some about reactance and there aren't anywhere, at least on the tech, where you have to know the formula for inductance, but you have to know what the term means.
Okay,
And it's the
something
ability
goes
to
back up
store
on-
energy in a magnetic field. Are we good?
We're good, thanks.
Okay. Which of the following conductors is preferred for bonding at RF?
Black copper strap?
D.
The copper braid that's on coaxial cable is fairly fragile. You'd have a hard time really getting it off in one piece, and it's not that heavy, particularly compared to the braid that I showed, and is nowhere near flat copper strap. Of course, the downside of flat copper strap is it's copper, and copper's expensive nowadays. I forgot what I paid for a 20-foot roll of like 2-inch was $50 or $60.
When you get hit by lightning, it's worth it.
Yeah.
It's worth the investment.
Yeah. It might lessen the effect. Okay, so for power supplies, you want to use the heaviest gauge that you can reasonably use, as short as possible. That you need to at least double the power requirement for your power supply from what your transceiver is. Remember how to hook up in to out, out to in between your computer and your radio for digital modes.
If you have a 50-watt transceiver.
Which is
and-
typical for mobile.
But you decided or was able to provide, say, 200-watt power supply. Does it improve the operation of it or just lengthen the time you can operate?
Well, if it was battery, yeah, it would lengthen the time you could operate.
How about if it's just not a battery, if it's direct,
Well, as long as it's supplying sufficient current, it's going to operate as long as it's plugged in.
but does it enhance?
No.
It just.
The transceivers are maxed out at whatever they.
They have their own voltage regulator internally,
Okay,
so they'll operate anywhere in the little over 12 volts up to a little over 14 volt in that range.
You have to swap out a few components in there.
If it gets too high, like up 16, 17 volts, you might blow a fuse in the radio.
okay, so. If you're going to buy this stuff. See a deal on a 200-watt, it's. Or if you just have excess money, it's not an enhancement to the operation, I guess.
In fact, most
Then you can operate multiple things.
of the power supplies that you're going to see, if you go to ham radio outlet or DX Engineering or Gigapar, any of the major are going to be in the 25, 30 amp range, which will run 100-watt.
What I
Transceiver.
just said, is that valid? If you have an overpowered power supply, you can run multiple.
Yeah,
Stations on the same power supply.
right.
Okay, so that's.
And also, if you've got a base station, you're going to have extra things that are gonna need to plug into that power supply.
Okay.
You might have a lighted SWR watt meter. You might have an external tuner. An audio equalizer like Heil cells to improve your audio. And most of those are designed to run off of your 13.8 volts.
Okay.
So that's why a 30 amp power supply with a 100-watt transceiver will give you enough extra that you can operate some of those other things.
Okay.
Oh, okay. Wasn't finished with the takeaways. And don't forget your ferrite beads. Put them on everything. You can't have too many beads each end. Or buy cables with them already on there.
I've seen cables with them already on there and. I've
Yeah,
seen it
those
without
little round
them.
lumps.
I noticed that they work better with it, but I never ever thought about putting them on. If it's missing, I think, oh, well, you know.
And if you get the
Designers know what they're doing, plug it in.
the ones with the larger hole, the larger size clip-ons, you can actually run like a USB cable or a microphone cable 2 or 3 times through that, which makes it 2 or 3 times more effective because it increases the inductance. And what you're doing is making the outside of the shield on those cables an inductor or choke. So you're blocking that common mode, which I don't know. I don't really talk about it that much in the technician.
Now you want me to go home and buy a pile of these things. And then run past the house, this one.
But they're fairly cheap.